The Lenovo Y530 has been highly requested on the channel, so I've bought one to find out how hot it gets and see if there's any throttling. In this video, I'll perform some detailed thermal testing and find out how overclocking and undervolting can help improve performance and temperatures. In my configuration here, I've got the Intel i5-8300H CPU with NVIDIA GTX 1060 graphics, so expect different results with different hardware. The i7-8750H, for instance, would probably be worse. Thermal testing was completed with an ambient room temperature of 25 degrees Celsius, so expect warmer temperatures in a warmer environment. Also keep in mind there are heat pipes shared between processor and graphics, so a change in one component may affect the other. Starting at the bottom of the graph, at idle the temperatures are a little warm, although the fan was completely silent. The gaming tests were done with Watch Dogs 2, as I find it to use a good combination of CPU and GPU. All gaming results were around the same, whether or not the CPU was undervolted by -0.15 volts, graphics overclocked by 180 MHz, or fan maxed out. The stress tests were done by running AIDA64 and the Heaven benchmark at the same time, in order to attempt to fully utilize both the processor and graphics. The results here also didn't change much. We're pretty much thermal throttling non-stop regardless of fan speed or undervolting in these combined CPU and GPU workloads. These are the average clock speeds for the same tests just shown. We can see that when the -0.15 volt undervolt is applied to the CPU, or the 180 MHz GPU overclock, the clock speeds rise up a fair bit. Much more compared to raising the fan speed, but as you'll hear soon, it was already running close to max speed at stock anyway, which is why there's not much of an improvement with max fans despite thermal throttling being the limitation. In all of these combined CPU and GPU tests, the CPU was never able to reach the full 3.9 GHz all-core turbo speed. We got closest with the undervolt applied and fans at full speed though. These are the clock speeds I got while just running CPU-only stress tests without any GPU load. At stock, it wasn't quite possible to reach the 3.9 GHz all-core turbo speed of the 8300H. However, it was possible with the -0.15 volt undervolt, shown by the green bar. These are the temperatures while running the same CPU-only stress tests. No thermal throttling here with the GPU at idle, but the CPU undervolt does improve the temperatures by 10 degrees Celsius. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here, with the older 7th gen i7-7700HQ just down the bottom for comparison. Check the card in the top right if you want to see a detailed comparison between these two CPUs. The single core result with the 8300H doesn't change as we only see power limit throttling under multi-core stress test, and this was only intermittent and can be reduced with the undervolt. Here are the GPU-only clock speeds while under a graphical-only stress test, and with a 180 MHz core overclock applied, on average there was a 140 MHz improvement under this workload. Here are the GPU-only temperatures while running the same GPU-only stress tests, and there's basically no difference with or without it overclocked, but still cooler compared to the combined CPU and GPU load testing shown earlier. So how does this performance boost actually translate into games? I've tested with the exact same Windows, Nvidia, and game updates installed. The only changes were the ones listed here. Far Cry 5 was tested using the built-in benchmark. The average frame rates at ultra settings was 6.4% better compared to stock speeds, and there was a 7% improvement to 1% low. So we are able to get a decent performance boost from overclocking the graphics and undervolting the CPU, though results will of course vary between game. As for the external temperatures where you'll actually be putting your hands, at idle it was in the low to mid 30s. With the stress tests running, the center of the keyboard gets to the low 50s, and then a very similar result while gaming, with the middle right up the back hitting the mid 50s, although that's probably fine as you only need to touch here when you use the power button. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle, it was completely silent. The fan wasn't running at all. While running the stress tests with the fan at stock, it's about average. A little louder while gaming, and then just a little louder still with the fan maxed out. While the gaming performance seems pretty good, it was a bit sad that even the i5 was seeing thermal throttling in combined CPU and GPU workloads, such as gaming. I can only assume the i7-8750H model would have to throttle back further, assuming that version uses the same cooling solution. I can't say for sure without testing though. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results. Primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements. So don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. And as I own this laptop, that could be something I try in a future video. I'm not sure if I'll bother though, given I saw no change after doing this to my Aero 15X recently. In any case, undervolting and raising the fan speed is much easier for anyone to do. And as we've seen, it did improve the performance a little in this particular unit, with no downside once you've got a stable undervolt. Let me know how much of a performance boost you found by undervolting your hardware, and what you thought of the improvements here. And don't forget to subscribe for the full review of the Lenovo Y530 gaming laptop, as well as future tech videos like this one.